Hey, this thing on? Yeah, it's on. Are you in there? Hello? Somebody want to turn the lights on? Hey, guys, Chapter 7, Section 5, Parts of Similar Triangles. There's nothing funny there yet. Wait, what's going on? Okay, I got something. Wait. No, I was wrong. Still got nothing funny about similar triangles. But hey, I tried. No, I really didn't. I'm sorry. No, I'm not. I'm not sorry at all. All right, guys. So, and let's start talking about special segments in similar triangles. Since corresponding segments in similar triangles and or polygons are proportional, this concept can be extended to other segments within triangles. All right, so if two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. So what they're saying here is this. The segment AD, which is the altitude of triangle ABC, to segment FH, all right, if those two triangles are similar, first of all, so if triangle ABC is similar to triangle FGJ. So the lengths of the altitudes AD to FH is the same as AB to FG, would also be, or let's say BC to GJ, or FJ to AC, okay? All those corresponding sides are proportional. All right, so if two triangles are similar, the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. So here we have triangle KLM and we have triangle QRS. And what they're saying here is in these two triangles, so I have KLM, which is here. Actually, it's on the side. I'm going to go with this. So triangle KL. So these two triangles are similar. And what they're saying is that the proportions of KLM to QRS, the scale factor, right, is the same when we have bisected these two angles. Also, if two triangles are similar, the lengths of the corresponding medians are proportional to the lengths of the corresponding sides. So if triangle ABC is similar to triangle WXY, then segment CD over YZ equals AB over WX. Okay, so those will be the same. All right. All right, so special segments in similar triangles continue. To sum this up, if two triangles are similar, corresponding altitudes, corresponding angle bisectors, corresponding medians are proportional to the lengths of the corresponding sides. I think it would be a great time to insert example problems here. And since I think it is, so in this figure, triangle ABC is similar to triangle FDG. Find the value of x. Well, since angle A and angle F are the corresponding angles, and they are being bisected, so those angle bisectors are going to be proportional. So we can set this up one of two ways. I can set it up as bisector over bisector, right? So we can say we'll go with the small bisector. 8 over x is going to correspond to 12 over 15. And when we multiply these through, I get 12x equals 120. So x is going to be equal to 10. We could also have done this the other way, which is to go from x over 15, let's say. Right, so bisector to side should equal bisector to side. And again, you still end up with the same cross multiplication as you did right here. And therefore the answer still is 10. All right, so here now we have an altitude. All right, MP is an altitude, YQ is also an altitude. So we'll do altitude to altitude, right? X over 16 is equal to 15 over 20. Now you just cross multiply, right? So 20x equals 15 times 16. Hey, let's pull out the handy dandy calculator. That's 240. So x is equal to 12. Right? And over here we have medians in this problem right here, problem 1b. And the medians here would have the same situation, right? So this segment here over this segment here is going to be equal to this over this, right? So let's go ahead and do that. So x over 3, let's go with x over 3 equals 13.5 over 9. So 9x is equal to 2.5 times 3 is that 40.5. So now you divide both sides by x, and that's equal to 4.5. So x would be equal to 4.5 once we divide that through. Okay, 4.5. All right, now triangle angle bisector theorem says an angle bisector in a triangle separates the opposite side into segments that are proportional to the lengths of the other two sides. So if segment JM is an angle bisector of triangle JKL, then KM over LM is equal to KJ over LJ. Okay. So if we take a look here, the ratio, this is, I've got an angle bisector here and here. So what that says is this length here, the relationship this length to this length, all right, KM over, I went to KJ, and that's both of this is true. So let's step back a second. Let's go back with the original. Let's erase this here and here. And let's put this in we'll go with black, that's fine. So the proportion between, the ratio between these two is equal to the ratio between these two. Now something interesting though is because of proportion rules, the relationship between these two, and I'll do these in red, is going to be equal to the relationship between these two here. So either way you set this up, you can solve. Hooray! It's time to insert more example problems here. So find x. Well, in this problem, you're going to have to do a little bit of thinking with this. I know that the relationship, I can say the relationship between these two is identical to the relationship between these two. So I don't know what this length is between ST, but I do know that since the whole length is 18, that this length is equal to 18 minus x, right? Because 18 minus x plus x equals 18. So I can set my ratio up now at 6 over x is equal to 14 over 18 minus x. So we're going to cross multiply now. So I get 14x is equal to 6 times 18, which is 108. Minus 6x. Right? 6 times 18. 16, 108. All right, so then we're going to add 6x to each side, and I get 20x equals 108. And then I have to divide each side by 20. And that's going to come out to 27 over 5, which is, what can that come out to evenly? 27 over 5, 5 and 2/5. So x is equal to 27 fifths or 5 and 2/5. Okay. Let's do the same thing over here now. All right. I can match this up over here between these two here, right, and these two here. So those are my matchups. Now I just set up my proportions. So x over 4 equals 13 over 6. 6x equals 52. Divide each side by 6. And I end up with 26 thirds, so x would equal 26 thirds, which is also equal to 8 and 2/3. All right, again, number 3b over here. We can set this up one of two ways. We could even set it up this way. We can set it up from here, and then we can set this up like this. So again, if this is x, this has got to be 20 minus x here. So let's set it up. 11 over 14. Let's go. If I'm going left to right, I'm going to go left to right over here. Equals 20 minus x over x. So I have 11x equals 280 minus 14x. I add 14x onto each side, and I've got 25x equals 280, and I divide 280 divided by 25, and I end up with 56 over 5. So when that's reduced, equals 56 over 5, which is equal to 11 and 1/5. Okay.
That's all, folks.
healthy.